Hello and welcome to gingergames. Today's video is about some advanced redstone techniques called logic gates. Now, if you haven't seen my previous video on redstone, it's Redstone for Dummies, please click the link on the description below or the annotation on the screen if it is available for you. Now, the first thing, all these redstone logic gates are available on the Redstone wiki. This is an image of all the gates that I'll be using from the Minecraft wiki. So let's start getting off with the first one, which is the InputOutput Gate. The InputOutput Gate is a simple thing. If you have an input, you have an output. So if the input is on, the output is on. Now if the input is off, output's off. Very simple, and it's very simple to make as well. The next gate is something called the NOT gate. Now what this does, if the input is off, the output is on, or if the input is on, the output is off. What this does is it inverts the signal, so it's not the same as the input, thus the name NOT gate. This is one of the fundamental building blocks of all logic gates in real life and in Redstone. Now, I won't go into it in a minute right now, but you can build any gate you like from this one and the next one. And this is very simple to build as well. The next gate is called the OR gate. Now this can take up as many inputs as it like. So if this input is on, the output is on. Or if this input is on, the output is on. Or if both are on, the output is on. Now this just means OR, so it doesn't matter which input is being put on, this will be on. Now this one and the other one are the fundamental building blocks of all logic gates. As you'll see in a minute, you can if you're clever enough, you can see how they're built together. The next one is called the AND gate. Now this means if this input and this input are on, the output must be on as well. So these are already on. Let's turn these off just to make sure. So if these are off, the output is off. If one of them's on, no, the output's still not on. If this one's on, nah, the output's still not on. But if they're both on, so that this one and this one is on, the output is on, as you can see. And this works as a NOT gate, two NOT gates connected up to another NOT gate. Now this is because so when this is on, this is off, and when this is on, this is off. But when one of these are on, this redstone is being supplied power, which turns this one off. So when both of these are off, this one becomes on, causing it to be on overall. So as you can see, there's 3 NOT gates. The next one is a bit complicated, but I'll show you what it is. This is called an exclusive OR, or a XOR gate, so pronounced XOR. And the name's not very descriptive of it, but I'll explain it to you just by showing you. Now if this one is on, the output is on, fine. Now if this one's on, the output's on. Easy enough. But if both are on, the output is off. Now you may be a bit wondering, why is it doing that? Now the reason for this gate is a real life example would be if you have a light in your house and you have 2 light switches going to the same light. If one of them's on, you can switch that. If you switch one of them on, the light goes on. If you switch the other one on, the other light goes off. Now this means you can control the light from multiple light switches. This is one of the uses for this. What it does is it detects the change in state of the outputs. Or simply put, if this is on, that's a change in state, the output changes. Now, if this is off, there's a change in state, the output changes. If this is on, that's a change in state, the output changes. Now, if I click that one, which are both on, it's a change in state, again, it changes, the output is off. So what it does, when it finds a change in state, the output changes in state. Now, I won't explain how this one works. There's simpler ones than this, laid out and everything, but this is the one they use on the Minecraft wiki. The next logic gate is something called the RSNOR Latch. Now this is that is not a very nice name for it either, but I'll explain it to you. So when this output is on and I click this switch, it toggles this one off and switches the other one to be on. So it has two outputs. And instead of using like a constant power supply, you just use a button. So when this one's on, that one goes off and that one goes on. So it toggles between the two outputs. Now this is extremely useful in many cases. For instance, if you literally want to toggle between them with two different switches, so you want this one on but not that one off, and vice versa. Use your imagination. Now the next logic gate is, it's not really a logic gate, it's called a 5 clock. And the 5 clock comes from its name having 5 torches, and it works like a clock. As you can see, this piston is pumping up and down at a constant rate like a clock. Now the reason why it's called a 5 clock is again 5 torches, and this is changing every 5 ticks. And a tick is a tenth of a second, so 5/10 of a second is a half a second. So this is 5 ticks, so it's a very useful clock. These sort of clocks, as you can see, are just a bunch of NOT gates all closed around a circle, only work with an odd number of them. Now if you have an even number of them, if you can guess, this pattern won't happen, because they'll all be on or off, and there'll be an even number of them. So if I'll show you actually, just to prove my point. So if I've turned this one on, this NOT gate here, and connect that one up, as you can see, all of these are on, off, on, off, on, off, and the pattern repeats. But when there's an odd number of them, it can't have that repeating pattern. So it's either on or off, but it can't do so, it just rotates around in circles. Now this is brilliant for making clocks or timed contraptions or something like that. Now the last two kind of gates aren't really gates, they're just something that you use in Redstone a lot. Now these are on the list. This is called the Redstone repeater. Now before the invention of the Redstone repeater here, which is now a block in itself like this, so if you want to extend a signal of redstone, it repeats it for you. Before we had these in the game, we had to kind of cheat a little. So the one that would come naturally to most people after learning these logic gates is called combining two NOT gates together. So this one and this one. So if I switch this on, it extends the signal. So all it does, that's two NOT gates. But the one I used to use all the time, which is this one, it's a bit more compact. Instead of taking 5 tiles, this one only takes 3. So as you can see, it's a bit more compact, and it does the same job. And this still has one NOT gate here and another NOT gate here. As you can see, when this is on, this goes off, which this doesn't power this, which makes this go on. And we used to have loads of these in the rows if you wanted to delays for them. So these were helpful. And the last kind of advanced redstone technique, which is not used that often, but it's, I don't know what to call it. I call it a redstone fizzer. Now I'll show you why. If I put some redstone in the middle for this contraption, as you can see, the redstone fizzes. Can I go and then it flashes like that? And this is kind of like a redstone randomizer. And these are useful if you want a randomizer, or if you want to flickly. So let's get a piston and just put it on the end. Wrong way. Look. Just go really fast and kind of random at pulses. So they're good for just mob traps and all that lot. Now, just before I go, you may be noticing I've missed a few of the items on the list. Now, this is because these are actually the ones with like N, like the NOR gates or the RSNOR gates or anything like that, are actually just the same number of same gates, but with a NOT gate on the end of it, so it just inverts the signal. So all those contraptions you've seen on YouTube, you can create them. It's your imagination's your only limit. Now, if you were confused by anything by this, please comment in the description below, or go to the Minecraft wiki and go and search for Redstone, or send me a private message on YouTube. That'll be great. So stay tuned for the next video, and goodbye.